There are homes in Europe that have been heated the same way for 500 years. These heating systems are still legal, but only because they existed before the regulations were written. If you tried to build the same system today, inspectors would shut you down. Permits would be denied. You might even face criminal penalties. These grandfathered systems continue operating while identical new construction is forbidden. The homeowners who inherited these ancient heating methods pay a fraction of what their neighbors pay for warmth. They have no monthly heating bills. Their systems require no electricity. They work when the grid fails, and they are illegal to replicate. It is a disturbing contradiction, but it is the truth. The most effective heating methods ever developed have been systematically banned, regulated, or forgotten. Not because they failed, because they succeeded too well, because they threatened industries worth billions, because they made people independent. Tonight I am going to show you 12 of these banned methods, what they are, why they work, why they were outlawed, and what scientists now say about their brilliance. The heating secrets they do not want you to know. Let us begin. Number 1. The Roman hypocaust. We begin with the most sophisticated heating system of the ancient world, the Roman hypocaust. A method so effective that buildings using it remained comfortable for over 500 years. The Romans constructed raised floors supported by brick pillars called pillae. These pillars created a 2-foot gap between ground and floor surface. A furnace burned wood continuously. Hot gases flowed through the space beneath the floor, heating it from below. Gases then rose through hollow wall spaces called tubuli before exiting through roof vents. The entire building became a heat distribution system. Floors radiated warmth upward. Walls radiated warmth inward. Heat that would escape up a conventional chimney instead transferred to living spaces first. Roman bathhouses maintained floor temperatures of 85 to 95 degrees Fahrenheit. These temperatures remained stable for hours after the furnace stopped. Thermal mass stored heat and released it gradually. One firing could warm a building for an entire day. Why was it banned? Modern building codes require sealed combustion systems. They prohibit open flame heating sharing airspace with living areas. They mandate specific clearances between heat sources and combustible materials. The hypocaust violates nearly every contemporary heating regulation. Scientists call it brilliant because it addressed human comfort directly. It heated bodies through radiation rather than heating air through convection. It maintained stable temperatures rather than cycling between hot and cold. It used thermal mass to store heat rather than generating heat continuously. The rule was thermodynamic genius. Heat the structure, not the air. The Romans understood this 2,000 years ago. We banned it and forgot. Method 2. The Korean ondol. While Rome developed the hypocaust, Korea independently invented an equally brilliant system, the ondol. For over 2,000 years, this heated floor system kept Korean homes warm through brutal winters. A traditional ondol begins with a firebox called an agungi, typically located in the kitchen. The fire used for cooking also generates heat for the floor. Hot gases travel through horizontal flues beneath the floor called gore. These flues wind back and forth, maximizing heat transfer surface area. Cooled gases exit through a chimney at the opposite end. The floor consists of thick stone slabs covered with clay and oiled paper. This mass absorbs heat and radiates it upward for hours after the fire dies. The brilliance lies in integration. Cooking and heating become one activity. No separate heating system is required. No additional fuel is consumed. Korean scientists found heat transfer efficiency of approximately 85%, far exceeding most modern systems. Traditional ondol floors maintained surface temperatures of 80 to 100 degrees Fahrenheit. This warmth persisted for 8 to 12 hours after the fire was extinguished. Why was it banned? Modern building codes prohibit combustion gases flowing beneath occupied spaces without sealed containment. They require specific chimney configurations that traditional ondol cannot meet. They mandate incompatible materials and construction methods. Traditional ondol can only be built in Korea under heritage exemptions. New construction must use modern water-based systems requiring electricity and pumps. Scientists call it brilliant because it achieved zero waste heating. Every BTU generated for cooking contributed to home heating. No energy was discarded. Complete integration created complete efficiency. Method. The Russian masonry heater. In frozen Russia, Survival required heating solutions for the harshest conditions on Earth. The Russian masonry heater emerged from this necessity, a system so efficient that one fire per day could heat an entire home. A Russian masonry heater is massive, weighing between 3 and 6 tons. It consists of a firebox surrounded by a labyrinth of channels constructed from brick or stone. When fire burns, hot gases travel through winding channels before exiting the chimney. With each turn, heat transfers from gases to masonry. By the time gases exit, they have surrendered most of their heat to the structure. The massive masonry then radiates this heat for 12 to 24 hours. A conventional fireplace allows gases to exit at 400 to 600 degrees Fahrenheit. A Russian masonry heater allows gases to exit at 150 to 250 degrees. The difference represents heat captured rather than wasted. Overall efficiency reaches 80 to 90% compared to a conventional fireplace at 10 to 15%. One intense fire burns for 2 to 3 hours each morning. Then no more fuel is added. The massive structure releases stored heat throughout day and night. Wood consumption drops to 1/4 of conventional requirements. Why was it banned? Modern codes impose weight limits that masonry heaters exceed. They require clearances the integrated design cannot provide. They mandate UL listing that handcrafted heaters cannot obtain. Scientists call it brilliant because it solved the fundamental problem of wood heating, continuous fuel consumption. By storing heat in mass, the Russian heater transformed an intensive daily chore into a simple morning routine. Method 4, the Kang bed stove. China developed an ingenious heated platform, the Kang, a raised structure serving as bed, seating area, and heating system combined. For over 2,000 years, the Kang kept northern Chinese families warm through winters rivaling Siberia. A traditional Kang is a raised brick platform approximately 2 feet high, large enough to accommodate an entire family sleeping side by side. Inside this platform, channels direct hot gases from a connected stove through the interior before exiting through a chimney. During the day, the Kang surface serves as seating and workspace. Families eat, craft, and socialize while sitting on the warm surface. At night, bedding is spread directly on the heated platform. The family sleeps directly on their heating system. The thermal integration is remarkable. Cooking generates heat that warms the sleeping platform. The same fuel serves multiple purposes. Heat is delivered directly to bodies through conduction, the most efficient heat transfer method. Kang surface temperatures range from 85 to 105 degrees Fahrenheit. The end nearest the stove is warmest, traditionally reserved for elders. Heat retention lasts 8 to 12 hours after firing. A family can cook dinner, heat the Kang, and sleep warm without additional fuel. Why was it banned? Modern codes prohibit sleeping surfaces with integrated combustion systems. They require separation between heating appliances and bedding. They mandate smoke and carbon monoxide alarms conflicting with traditional operation. Scientists call it brilliant because it eliminated the middleman. Instead of heating air to heat bodies, the Kang heated bodies directly. This directness created efficiency that air-based systems cannot match. Method 5. The Finnish contraflow heater. Finland contributed perhaps the most refined masonry heater design ever developed, the contraflow heater. A system of such elegant engineering that thermal scientists consider it nearly perfect. In a conventional chimney, hot gases rise straight up and exit. Heat escapes with them. The Finnish contraflow forces gases through a more complex path. Gases rise from the firebox, then descend through channels on one side, then rise again through channels on the other side. The name comes from this alternating flow. Hot gases and cooler gases flow in contrary directions in adjacent channels. Heat transfers from hotter to cooler passages through shared masonry walls. By the time gases reach the chimney, they have surrendered nearly all usable heat. Exhaust temperatures drop to 150 degrees Fahrenheit or lower. Efficiency reaches 90%, approaching the theoretical maximum for combustion heating. One loading of wood heats the structure for 18 to 24 hours. The Finnish government found that properly constructed contraflow heaters reduced wood consumption by 60 to 70% compared to conventional stoves. Air quality improved because complete combustion produced minimal smoke. The construction requires precision. Channel dimensions must follow specific ratios. Masonry thickness must be calibrated to thermal mass requirements. Finnish masons passed construction secrets through apprenticeship for generations. Why was it banned? Modern codes require manufactured heating appliances with certified performance ratings. Handcrafted masonry heaters cannot obtain these certifications. Codes impose requirements written for metal stoves that masonry heaters cannot meet. Scientists call it brilliant because it approached theoretical perfection. The contraflow principle extracted virtually all available heat from combustion. No modern manufactured appliance matches its efficiency. Number Method 6. The Afghan Sandali. Afghanistan developed a heating approach that inverted modern assumptions entirely. The Sandali. Instead of heating rooms and hoping warmth reaches bodies, the Sandali heated bodies directly. A Sandali consists of a low table covered by a large quilt or blanket. Beneath the table, a container holds hot coals, typically charcoal from the cooking fire. Family members sit around the table with their legs underneath and the quilt draped over their laps. The coals radiate heat directly to the bodies gathered around them. The quilt traps this heat, creating a warm microclimate for everyone seated. The room itself may be cold. The people are warm. A Sandali heats perhaps 20 cubic feet of space. A conventional heating system attempts to heat 2,000 cubic feet or more. The Sandali requires 1% of the heating volume. It uses proportionally less fuel. Afghan families survived freezing winters with handfuls of charcoal. The same heat that would barely affect room temperature created genuine comfort when applied directly to bodies. Social integration enhanced the system. Families gathered around the Sandali for meals and conversation. Warmth and togetherness combined. Some designs included the corsi, allowing users to sleep with their bodies under the heated table. Why was it banned? Modern codes prohibit open flame or hot coal heating in living spaces. They require vented combustion. Fire codes prohibit combustible materials near open heat sources. The quilt draped over the Sandali violates these provisions automatically. Scientists call it brilliant because it questioned the fundamental assumption of space heating. Why heat empty air when you can heat occupied bodies? The Sandali answered with radical efficiency. Number Method 7. The Germanic Kachelofen. Germanic Europe developed the Kachelofen, a tile stove combining artistic beauty with thermal engineering. For centuries, these massive ceramic structures heated homes across Germany, Austria, and Switzerland. A Kachelofen consists of a firebox surrounded by a labyrinth of channels, similar to Russian masonry heaters. But the exterior is covered with specially designed ceramic tiles. These tiles are not merely decorative. They are engineered for heat transfer. The tiles conduct heat from interior masonry to room air. Their surface area is maximized through three-dimensional designs. Ridges, curves, and projections increase the radiating surface. Beautiful patterns serve thermal functions. Kachelofen efficiency ranges from 80 to 90%. Surface temperatures remain comfortable to touch, typically 150 to 170 degrees Fahrenheit. This lower surface temperature allows placement against walls without fire risk. One firing per day maintains comfort. Traditional Kachelofen tiles have specific thermal conductivity, designed to transfer heat at optimal rates. Too conductive and the stove cools too quickly. Too insulating and the stove becomes dangerously hot. Traditional formulas balance these requirements perfectly. The tiles also expand and contract with heating cycles. Traditional designs accommodated thermal movement through shape and composition. This knowledge was guild-protected for centuries. Why was it banned? Modern codes require clearances that Kachelofen designs cannot meet. They mandate listed appliance ratings that custom masonry cannot obtain. The specialized tiles are no longer manufactured. Traditional formulas have been lost. Scientists call it brilliant because it optimized every element. Structure stored heat. Tiles transferred heat. Aesthetics motivated proper maintenance. Form and function integrated perfectly. Number Method 8. The Japanese Kotatsu. Japan developed a heating philosophy fundamentally different from Western approaches. Instead of heating entire homes, they heated specific activity zones. The kotatsu represents this philosophy perfectly. A traditional kotatsu consists of a low wooden table frame with a heat source underneath. A heavy blanket is draped over the frame, extending to the floor. Family members sit on floor cushions with their legs under the table and blanket covering their laps and lower bodies. Historically, the heat source was a charcoal brazier placed in a recessed floor pit. The kotatsu heats approximately 15 to 20 cubic feet of space. A central heating system heats 2,000 cubic feet or more. The kotatsu uses less than 1% of the energy to achieve equivalent personal comfort. Japanese families traditionally kept room temperatures at 50 to 55 degrees Fahrenheit, far below Western standards. But bodies gathered around the kotatsu felt perfectly warm. Targeted heat eliminated the need for space heating. Families ate meals at the kotatsu. Children did homework at the kotatsu. Adults read and conversed at the kotatsu. The heating system organized domestic life. Some traditional homes included sleeping arrangements at the kotatsu. The blanket extended to cover sleeping bodies. Why was it banned? Traditional charcoal kotatsu face strict regulations. Open combustion in living spaces violates modern codes. Carbon monoxide concerns prohibit unvented charcoal burning. Fire risk from blankets near heat sources triggers violations. Scientists call it brilliant because it challenged the heating paradigm itself. Why heat empty space? Why maintain room temperatures serving no occupied purpose? The kotatsu answered by heating only what needed heating. Method 9. The rocket mass heater. This method represents a modern synthesis of ancient principles. The rocket mass heater combines insights from Roman, Russian, and Asian traditions into a system of extraordinary efficiency. Developed in the 1980s, it was almost immediately targeted by building codes. A rocket mass heater uses a J-shaped combustion chamber, creating extremely hot, complete combustion. Temperatures in the burn tunnel exceed 1,800 degrees Fahrenheit. At these temperatures, wood gases burn completely, producing minimal smoke and maximum heat. Hot gases flow through a barrel heat exchanger, transferring heat through radiation and convection. From there, gases travel through a horizontal mass of cob, brick, or stone, typically shaped as a heated bench. This mass absorbs heat and releases it over many hours. Rocket mass heaters achieve efficiency ratings of 80 to 90%. They burn wood at rates far below conventional stoves. Small branches and scrap wood suffice for fuel. One wheelbarrow of wood can heat a well-insulated home for an entire day. The heated bench adds a direct comfort element. Users sit on the warm mass, receiving conducted and radiated heat directly. Emissions approach zero visible smoke. Complete combustion eliminates creosote formation. Why was it banned? Building codes require manufactured appliances with EPA certification. Rocket mass heaters are built on site from common materials and cannot be certified. Codes require specific chimney heights that the cool exhaust does not need. Insurance companies refuse coverage for homes with rocket mass heaters. Scientists call it brilliant because it optimized combustion itself. The rocket principle creates temperatures extracting maximum energy from fuel. The mass principle stores heat for extended release. Method 10. The Trombe wall. French engineer Félix Trombe developed this passive solar heating method in the 1960s, building on principles understood for centuries. The Trombe wall captures solar energy and releases it as heat with no fuel consumption whatsoever. A Trombe wall consists of a dark-colored masonry wall positioned behind a glass panel on the south-facing side of a building. Sunlight passes through the glass and strikes the dark wall. The wall absorbs this energy and heats up. The glass prevents heat from escaping back outside. The heated wall transfers warmth to the interior through two mechanisms. Radiation from the warm inner surface heats the room directly. Convection through vents at top and bottom circulates air, drawing cool room air, heating it, and returning it warm. A properly designed Trombe wall can provide 30 to 45% of a home's heating needs with zero fuel consumption. In sunny climates, this percentage can reach 60% or higher. Heat storage in masonry provides warmth after sunset. The thermal mass delays heat transfer by 8 to 12 hours. Heat absorbed during afternoon sun radiates into the home during evening hours. The system requires no moving parts, no electricity, no maintenance beyond occasional glass cleaning. Why was it banned? Modern codes impose window-to-wall ratios limiting glazing area. Energy codes penalize Trombe walls because they increase calculated heat loss through glazing, even though they provide net heat gain. Fire codes require egress windows that Trombe walls may block. Scientists call it brilliant because it harvested free energy. The sun delivers approximately 1,000 watts per square meter. The Tromba wall captures this gift without combustion or pollution. Number method. 11. The earthen thermal mass floor. Ancient builders discovered that Earth itself could store heat for months. By integrating massive earthen thermal mass into floor construction, they created systems capturing summer warmth and releasing it during winter. The earth below a building maintains relatively stable temperatures year-round. At depths of 4 to 6 feet, soil temperature approximates the annual average air temperature, typically 50 to 55 degrees Fahrenheit in temperate climates. Traditional earthen floor construction enhanced this effect. Thick layers of tamped earth, stone, or adobe created thermal mass directly connected to the ground. This mass absorbed heat during summer months and released it during winter months. Passive solar designs amplified the effect. South-facing windows admitted winter sun striking the thermal mass floor. The floor absorbed this energy and released it during evening hours. Summer sun higher in the sky was blocked by roof overhangs. Properly designed earthen thermal mass floors can maintain interior temperatures of 60 to 68 degrees Fahrenheit through winter with minimal supplemental heating. Summer cooling works through the same mechanism. The cool thermal mass absorbs excess heat, moderating temperature swings without air conditioning. The system lasts indefinitely. No components to fail, no maintenance required, zero operating costs. Why was it banned? Modern codes require moisture barriers between soil and living spaces. These barriers interrupt the thermal connection. Codes require minimum floor temperatures earthen floors may not meet. Foundation requirements mandate concrete slabs, eliminating direct earth contact. Scientists call it brilliant because it used the earth as a battery. The massive thermal reservoir stored energy across seasons. No manufactured system matches this storage capacity. Method 12. The greenhouse-attached solarium. The final banned method combines heating with food production. The attached greenhouse captures solar energy while growing plants contributing to the thermal system. Ancient versions fed and heated families simultaneously. An attached greenhouse on the south side of a home acts as a solar collector. Winter sun enters through glazing and heats the interior. This heated air circulates into the main home through vents or openings. Plants in the greenhouse contribute to the thermal system. During photosynthesis, they absorb solar energy. At night, they release this energy as heat through respiration. A well-planted greenhouse generates more stable temperatures than an empty one. Water features and thermal mass in the greenhouse store additional heat. Barrels of water, stone walls, or earthen floors absorb daytime warmth and release it overnight. An attached greenhouse can raise adjacent room temperatures by 10 to 20 degrees Fahrenheit during sunny winter days. Night heat release continues warming for several hours after sunset. Food production provides secondary benefits. Fresh vegetables during winter, herbs for cooking and medicine. The microclimate extends growing seasons by weeks or months. Plants that cannot survive outdoor winters thrive in the protected environment. Why was it banned? Building codes impose separation requirements between habitable spaces and agricultural uses. Fire codes restrict glazing areas that attached greenhouses exceed. Energy codes penalize heat loss through glazing without crediting heat gain. Zoning regulations prohibit greenhouse structures. Homeowner associations ban them for aesthetic reasons. Scientists call it brilliant because it integrated multiple survival needs. Food, heat, humidity, light. The attached greenhouse addressed all while reducing resource consumption. The synthesis created unmatched efficiency. Let us return to where we began. Homes in Europe heated the same way for 500 years. Systems that work perfectly. Systems that cost almost nothing to operate. Systems that are illegal to replicate. Now you understand why. The Roman hypocaust heated floors with combustion gases, banned because gases cannot flow beneath living spaces. The Korean ondol integrated cooking and heating, banned for the same reasons. The Russian masonry heater burned once daily, banned because it cannot be factory certified. The Chinese Kang heated beds directly, banned because sleeping surfaces cannot contain heat sources. The Finnish contraflow achieved near-perfect efficiency, banned because custom masonry cannot meet code requirements. The Afghan sandali heated people instead of spaces, banned because open coals violate fire codes. The Germanic Kachelofen combined art and engineering, Banned because traditional tiles no longer exist and clearances cannot be met. The Japanese kotatsu targeted heat precisely. Banned because charcoal cannot burn indoors. The rocket mass heater synthesized ancient principles. Banned because site-built systems cannot be certified. The tram wall harvested free solar energy. Banned because energy codes cannot calculate its benefit. The earthen thermal mass floor stored seasonal heat. Banned because moisture barriers are required. The attached greenhouse grew food and warmth together. Banned because agricultural and habitable spaces must be separated. 12 methods, 12 bans, and 12 scientific verdicts of brilliance. These methods were not outlawed because they were dangerous. Traditional users operated them safely for centuries. They were outlawed because they threatened industries that profit from your dependency, because they could not be metered, monetized, or controlled. The knowledge still exists, in grandfather clauses, in heritage exemptions, in communities that rejected modern convenience, and now in your mind. If this exploration gave you something valuable, hit that subscribe button. Share this with anyone who pays too much for heat. Share this with anyone who wants independence from systems designed to create dependence. And now one question for you. Have you experienced any of these banned heating methods? Have you seen them in old homes or foreign countries? What was the experience like? Share your story in the comments below. Someone else might learn from your experience. Stay warm. Stay independent. And I will see you in the next deep dive.